Okay, so on this question, it says, Americans receive an average of 17 Christmas cards each year. Suppose the number of Christmas cards is normally distributed, like bell curve, standard deviation 6. Let X be the number of Christmas cards, blah, 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 blah. Okay, so that N, that stands for the normally distributed. And what we do here, we just always put the mean and the standard deviation. What was the mean? Oh, average is mean. 17 standard deviation is 6. Okay. If an American is randomly chosen, probability no more than, yeah, that's a good question. What does that mean if you receive no more than 11? Doesn't that mean 11 or less? Does that make sense? That's just a different way of saying 11 or less. If you got no more than 11, meaning you didn't get 12 or 13 or anything like that, you got no more, not more than 11. So it's 11 or less, right? So, okay, so what do we always do? We draw those as a bell curve. Let's do that. And bell curve thing. And then you put the middle on there, and the middle is the mean, 17. Okay, that's the average, right? I get that right here. Now, what am I going to do from here? Well, 11, where's 11? So remember, you always put whatever they're asking for. They're saying 11 or less. You put that in the thing, so 11 would be down here. And now, which way are we going to shade? So you put the number that they say on the graph, and then you shade to the right or to the left, depending on whether they say more or less, greater or smaller. They said less, so I'm going to shade to the left, like that, because that's less. Less is to the left. If they said more, it'd be to the right. They said no more, so no more means less, doesn't it? It's not more, it's less, right? No more. Sorry, I keep scribbling this up. No more means less. Are we good? This making sense so far? No more means less. Okay, now notice the shading goes off to the left forever, doesn't it? So that's going to be negative 5 nines. If you ever go to the right forever, that's positive 5 nines. We're basically trying to say positive infinity. I don't know if you know the infinity symbol, it's a sideways 8, whatever. It's basically, I'll just write infinity. It's basically positive infinity or, negative infinity. And the reason for that is it's like a number line. It's like, you guys know about like number lines, it's like a number line where you have like 0 in the middle, and then this is positive 1, positive, etc. So way off to the right is positive infinity. And the way we say that is 5 nines. And then to the left, you have negative numbers like negative 1, negative 2. And so way over here is negative infinity. You know what I mean? So just think about a number line with 0 in the middle, and you go to the right, the numbers are positive, go all the way to the right, it's positive infinity, all the way to the left is negative infinity. So that's what the bottom of the bell curve is. So the right side is positive infinity. The way we do infinity is just 5 nines, because that's just like a giant number, because we can't put in infinity. We have to put in a really big number. So that's all I'm doing. You can put in 6 nines or 7 nines. It's all good. It'll work the same. You're just putting in a giant number, which the calculator will basically calculate as infinity. Or to the left edge forever, it's negative infinity. So, all right, so now we're ready to go as far as to the calculator. And so what do we do in the calculator? Well, if you look back at the notes, the notes tell us right here, here's the exam 2 notes. They tell us it's either, are they asking for a percentage or giving a percentage? Well, on this one, they're asking for a percentage. So we're going to use normal CDF. You might wonder, well, where did they ask for a percentage? How do you know they're asking for a percentage? Well, because they said, find the probability. Probability is a percentage, huh? Right? If I said, what's the probability to range today? You'd say like 10% or whatever. It's a percentage. So they're saying, find the probability. They're asking for a percentage. They're asking for a probability, which is a percentage. Okay, so that means I'm going to do normal. So you're going to, go second and vars and normal CDF. Okay, and then when you do normal CDF, it's going to be, it says lower, upper, mean, and standard. Or has that mu and S, and those are mean and standard, mean and standard. Okay, now, but now what do we do? So I'm just getting scribbly here. It's making a mess out of that. I'm going to do a quick arrow there. Okay, so now what is, when it says that lower and upper, do you know what it means by lower and upper? I think that's a sticking point for some people. It means left side of the shading. That's what it means by lower. So that would be over here. So that's the negative 5 nines. Huh? And then the next one, the upper, means the right side of the shading. And that would be the 11. Is that making sense? So you're looking at this piece of shading right here. And you're saying, what's his left side? What's his right? You think, what about 17? Well, the shading doesn't touch the 17, does it? So I'm not going to, now the 17 will go down here. The 17 is the mean and the standard deviation is, what was it, 6. But as far as the lower and the upper, we mean the left side and the right side of the piece of shading. So that's why it's important when you draw your bell curve to make sure you put the shading on your curve, because that'll tell you the left is the lower and the right side of the shading is the upper. That's what I mean by lower and upper, left side, right side of the piece of shading. You're basically telling your calculator, hey, calculator, the shading goes from negative infinity, negative 5 nines, up to 11, calculator. That's where the shading is. You're telling that you're communicating to your calculator. You're saying, calculator, I want you to tell me how much is here if the shading goes from negative 5 nines up to 11, lower, upper. When the middle is 17 and the standard deviation is 6, tell me how much you got and hit the buttons, and the calculator will tell you. And now remember, you've got to round your answer, doesn't it say? Yeah, right here. Round all answers to 2 decimal places. So like I'll go to my calculator on this one. And clear it. So I'm going to go to second vars, go down to normal CDF, enter. Okay, my left edge is going to be negative 5 nines. You could do 6 nines, whatever. It's just negative infinity. My upper, my right edge of my shading is 11. My mean is 17. And my standard deviation is 6. Hit enter a couple times. And there we go, 0.00383. Let me write that down. 0.00383. 0.00383. Okay, now let me go back. That's going to be interesting to put it into 2 decimal places. I want to help you with that. Let's go back. Okay, so remember, this is going to be a weird one to round. Take a look at this. You might want to dial in if you're not really paying attention because you're doing something else. You might want to dial into this. This will be interesting. So we're supposed to take this number right here, and what we just got from the calculator. We're supposed to round it to 2 decimal places. How do you do that? Well, remember, you put the line after the second place, right? 2 decimal places, put the line, because they told me up here 2 decimal places. So then that 3 tells me to what? Just leave it. So the answer is 0.00. Isn't that bizarre?
Mr. Heron, are you putting, when you put the negative 9, do you have to put a point on there too?
The 5 nines?
Yeah, when you're entering the formula, because for the lower it's negative 9, right? Because I got a different answer, so I'm putting negative.
The lower is negative 5 nines, no decimals.
And then 11, 17, and 6, and then paste. And I'm getting 1586.
I am too.
Yeah, I got the same thing.
Maybe I did something wrong.
And then you round up to 0.16.
See what I did wrong. Let me see. Second vars, normal CDF. Okay, negative. Oh, my upper's only 1. It should have been 11. Thanks, guys. I messed up. 0.1586. Is that what y'all are getting?
Yeah. So is it 0.16 then the answer?
Yeah. Good job. Good job. Yeah. My mistake. Let me write down 0.1586. Yeah. Thanks. I put in 0.1 instead of 0.11. You guys saved it there. Saved me there. Let me go back to sharing the iPad screen. Thanks. I thought we had a really weird answer. I was all going off on what we're going to do about this weird answer. I guess I just need to fix my weird answer. All right, let me try again. It's not going back to the iPad. Come on. There it is. Okay, yeah. So then, yeah, you round it. You're exactly right. You're going to cut it right there, second place. That 8 says round up, 0.16. Thank you. You're right. All right, good. Now, part C will be actually a little bit easier. Part C says an American is randomly chosen. Probably the American will receive between 10 and 20 Christmas cards. So 10 and 20, that's not too bad. So kind of running out of room here. Let me drop on down. So between 10 and 20, just draw the bell curve again. You know, it's all about these bell curves. And bell curve, the middle wasn't it 17, I think, on this one? Yeah, the middle 17. Between 10 and 20, where's 10 and 20? Well, 10 is like over here. 20 is right there. So you want the shading between 10 and 20. So that's easy. That's just going to be normal CDF, and then the lower and the upper. So this time we don't have any of the 999 stuff. Why? Because, I mean, the 999 is still there. You know, positive 5 nines is way over on the right and negative 5 nines is way over on the left. But notice the shading stops at 10 and 20. It doesn't go all the way to the right or go all the way to the left. So the lower is just 10 and the upper is just 20, right? Because remember, lower is the left edge and the upper is the right edge of the piece of shading. And then the mean and the standard, whatever those were, the mean is 17. Standard was it 2? 6. 6. And just put those in and you get your answer. So those are actually easier. It's easier when the shading doesn't go right or left forever. You don't have to use the positive 5 nines if it goes right forever, or negative 5 nines if it goes left forever. This one stops at 10 and 20. So the lower and the upper, the left edge and the right edge of the shading is just 10 and 20. So that's for part C.
How did you get your 17 and 6?
That they gave me that up here.
Beginning. Yeah, okay.
Thank you. Yeah, it's the average and the standard. And then part D says 63% of all Americans receive how many Christmas cards? 63%. Receive at most. That's an interesting question. Okay, so 63% of Americans receive at most how many Christmas cards? Yeah, that's a little tricky. Let's see if we can draw that. Got to draw the bell curve. So what does at most mean? At most means, well, here, let me draw it. Bell curve. If I can squeeze it in here. And I'll put the middle, which in the middle is 17. Okay, 63% of all Americans receive at most how many Christmas cards? Well, if that's going to be a number somewhere to the right. How do I know? Because this part has got to be 63%. It's got to be 0.63. And then this is what I'm looking for down here. What is that spot? How did I come up with that? Well, at most, means that or less. At most means that or less. If I say, hey, I've got at most 5 coins in my pocket, that means I have 5 or less, huh? The most I could have is 5. I might have less. So when they say at most how many Christmas cards, they mean that or less. So that's why I shaded to the left. Is that making sense on that phraseology? So when they say at most, when somebody says at most, if I say I've got at most 5 coins in my pocket, that means I have 5 or less, doesn't it? The most I could have is 5, I might have less. So when they say at most how many Christmas cards, they mean how many Christmas cards or less is 63% of all Americans. So the percentages always go up in the curve. Have you noticed that? The percentages always go up there in the curve. So are we going to do normal CDF or inverse norm? Well, if you look back at the notes, they gave us a percentage, didn't they? So if you look back at the exam 2 notes, here it is, here's the exam 2 notes. When they give you a percentage already, like they gave us 0.63 on this one, use inverse norm. Area left means standard, inverse norm. So we're going to do inverse norm on this one. So we'll come on down here. There it is. And we'll do inverse norm. So, okay. Inverse norm. And it says area means area left, and that'll be the 0.63 because that's the area to the left. And the mu and the sigma, that's the mean and the standard, 17 and 6. Type those in, hit the buttons, and you'll get an answer, and you round that to 2 decimal places. And so there we go.